If you've written web code, you've dealt with CORS before. It's not particularly fun dealing with cross-origin request stuff. You might have even seen my tweet that I made last stream where I was complaining all about CORS. It has consistently been a pain point for things I and many developers have worked on, but why? How do we get here? What are the problems CORS is supposed to solve, and why isn't it doing that? Let's break it down. First, I want to showcase this tweet, me complaining, because CORS is straight pain, and this tweet's response really shows it. The vast majority of developers that have worked with CORS have had a bad experience with CORS. There's also this wonderful diagram that was linked in chat. Help, I have a CORS problem, and it's a hilarious flowchart. You ruled out quitting tech to become a woodcarver. For me, it's a farmer or a skateboarder, but same difference. Quit tech and become a woodworker. If you've considered that, but you're staying in tech, do you control the server? Have you allowed? Yes. Really? Do you need to send a pre-flight options request? Will that help? Nope. No, Godspeed. Yep. I went through all of this yesterday, which is why we're talking about this today. I had a miserable experience trying to get upload thing working in StackBlitz. So if CORS has so many problems, what is it actually solving? Why have we built this in the first place? Well, first I want to draw a distinction between same-site origin rules and cross-origin request scripting. The same-site origin rule had a specific goal: make it so that a website can't access data, more importantly, cookies from other websites. If your website had a button that when clicked would trigger a script call that would go hit the Twitch sign out endpoint, you'd allow users on another website to sign out from Twitch or request data that's requiring specific permissions. Same site request rules were to make sure the JavaScript on your site couldn't request endpoints on other websites, which was mostly good. But once we had more complex infrastructure, maybe you have 3 different web services that are all accessing the same API. How do we deal with all of that? That's what CORS was designed to solve, and whether or not it did is up for argument. But it does make it possible to have one web service, one domain that exposes stuff that's accessed from another place. This doesn't work for local hosts, sadly. So if you have a server running locally and you want a web service to have access to it, you have to use sockets, which is really funny that sockets don't support any of these checks, and you can just access a local WebSocket or anything locally over a socket connection, even though you can't do it over a traditional API call. Regardless, these are pain points we deal with in order to make good software with web applications that request things from all over the internet. So why am I talking about this now? What problems did I have? I was trying to make upload thing work in StackBlitz, which is a browser-based IDE. StackBlitz uses web containers to run backend code in the browser, which means that if your service gets hit by that backend code, it now has to honor CORS. Before we were supporting StackBlitz, all of the requests to our service at upload thing were going through backend code that was running on a node instance or an edge instance or something that was running from a backend, not in a browser. But since StackBlitz is running that in the browser, we end up having significantly more complexity. And God, did I deal with a lot of pain trying to get this working just right. One point in here is particularly funny. So the first thing I did was I updated our API helper code for the API endpoint that is affected to update the CORS headers directly. So if you see here, I stole this code from Julius, set CORS headers. This takes in a response and it sets all of these properties. We were pretty blind with the just supporting star stuff here. And again, this is just for the upload thing pre-signed URL generator when you hit the service asking for the pre-signed URLs that you then forward to the client. And somewhere in here, when I'm sending the actual response, I set the CORS headers on it before I send it. Pretty traditional, boring stuff. And this didn't work. Why didn't this work? Well, originally, I only applied this on the post call because with App Router, you don't set requests per route. You set them per route and per type of request. So post requests had the right CORS set. Option didn't. So what I ended up doing is I deleted all that code I just showed you. I added the options call, which is the pre-flight call that the browser makes before fully honoring the request. I don't feel like reproducing it, so here's a screenshot of when it was happening. The backend's only making this one prepare upload call, but since it's running in the browser, it's actually making a second call here, which is an options call. So what I was having before is this would technically pass if it could go, but before the browser actually lets this action go through, it runs this first. And if this doesn't come back with a satisfactory answer in terms of the CORS policy, it will auto-fail this request, which would then for us auto-fail the request causing all of this to happen, which was a really weird dependency chain to determine what was going wrong. Because this request triggered this request, which triggered this options call, and this options call needed to have a specific response. So I fixed that. I gave it the specific response. And that's actually what caused this screenshot, where this options call passed and this repair upload call failed because this had a more permissive CORS policy than this did. So I had to write effectively the same code twice, where the options call responds with these headers and nothing else. And then the post call has to fill the request response with the same stuff, which is obnoxious because the browser couldn't decide which way it wanted to use to honor CORS policy. So they said, why not both? And forced you as the developer to do twice as much work and make sure it's perfectly synced, thereby doubling the chance you have an issue in the future because you might change it in one place but not the other. And that's a huge risk to deal with. And funny enough, this CORS policy we're doing on repair upload is applied to the post on other things, but since we didn't also apply the option call, it won't work. It's obnoxious that I now have to write these two different behaviors to serve the same set of data in hopes of getting this working for what for us is an edge case, which is people running the backend code in the browser. Absolutely obnoxious, to the point where the StackBlitz team is actually working on proxying these calls themselves just to get around dealing with these CORS policy rules. There's also apps that are similar to Postman, like Hopscotch. And the way Hopscotch solves this problem is they actually have a Chrome extension. I don't know if it shows that here anywhere. Oh, here it is. The Hopscotch browser extension. The reason this is here is so you can skip the origin checks because they can run it behind the scenes in Chrome. And the only way you can do an API request from a service that doesn't have all their core stuff set up perfectly is to proxy it in some way, which is obnoxious. It makes developer setup and overall experience absolutely miserable. On top of that, you can get around a lot of the local stuff and a lot of the weird policy things here just by using a WebSocket, because WebSockets don't honor any of this stuff for some reason, which is just stupid. This is why everybody hates CORS. This is why there's diagrams like this. This is why I made multiple tweets about CORS that almost all blew up. Yesterday, Jira was down because of CORS. Jira is not accessible for some users due to CORS errors. Suddenly I like CORS is what I said. And I cursed myself because I ran into multiple hours of CORS issues after. This is at 7:03 p.m. that I said I've been fighting CORS issues for 2 hours. This was at 1:07 a.m. So that's another 5 hours. And then it turned out I was wrong. I didn't actually fix it. It took me another 30 minutes to realize that. And then finally got it all working later. Actually obnoxious to get all of this set up properly. Yeah, this is a big part of why I went to bed so late last night, yes. So yeah, the state of CORS, it's a little bit tragic. It's important that it exists because it enables applications to do more complex things, but the same site request policy, despite having good intentions and preventing a lot of potential security issues, is a pretty painful thing. If it was easier to work around these things, if there was better standards to do CORS correctly and set up cross-origin requests, this wouldn't be such a negative video, but sadly that's not the way things are. And if I'm frank, the only thing that's more obnoxious and more likely to be the source of a problem than CORS, as for us web devs, it's almost certainly DNS. That's all I have to talk about with CORS today. If you want to hear me complaining about more weird web standard stuff, I'll pin a video in the corner all about that. And YouTube seems to think you're going to like the one that's right there, so you should check that out too. Appreciate y'all. Peace, nerds.